So yesterday we had that little half sheet with the factoring on it, right? And then the very last example was a sum of cubes. And I said we were going to take more notes on it today. So the piece of paper that you just got is all about sum or difference of cubes. And the back side of it is practice. I'm not taking a grade on the back side. I just put a lot on there so that you can practice them. Because once you see how to do it, you're going to realize like you can finish that back side in less than 5 minutes. Because it's a pattern. There's actually no, in my opinion, I would say there's no factoring involved because it's just a pattern. And then you plug it into the pattern and then bam, it's factored. So first of all, what you need to know is that there's 2 cases. There's the sum or the difference. Sum or difference. The 2 cases still factor the same way, using the same pattern. You will notice that your paper has the 2 cases written out right here. This is the multiplied product form, and then this is the factored form. And then you have these giant arrows telling you about the signs. So I was going to show you an acronym to help you with factoring both and never get the signs wrong. And the acronym is SOAP. And I'm going to preface that by saying always use soap. Always use soap, right? Here's what I mean by SOAP. It's an acronym to stand for it's the same sign, opposite sign, and then always positive. Same, opposite, always positive. That's how you get the signs when factoring a sum or difference of cubes. How do you get the numbers or variables? First of all, the original problem should be perfect cubes. So this is where we will make a list of the first like 6 or 7 cube numbers, and you need to memorize them. Kind of like perfect squares you have memorized, or you're just comfortable with them. 4 is perfect square, 9 is perfect square, 16, 25, 36, yada, yada, yada. We're going to write the first 6 or 7 cubes, and you need to get comfortable with them, and it makes this a lot easier, okay? To get the numbers, you should notice the pattern. The cube root of each term is the first binomial when you factor it. So you cube root. When I do a practice problem, this is probably going to make more sense. Just watch and let me say this part first. Take the cube root, and that's your binomial. To get the trinomial, you will notice that the outer elements are the square of the binomial, right? A squared, B squared. And notice the middle element is the 2 multiplied together. It's a lot, I know. So here we go. Cube root, binomial. Take that, square it. Take that, multiply it together. Signs are SOAP. Same, opposite, always positive. Go to number 1 on the back. Actually, before we start one, go to the bottom of your paper where there's room. Let's write the first 7 cubes. We're going to say perfect cubes. So 1 cubed. 1. Seems irrelevant, but it comes up. So don't forget it's a cube. 2 cubed.
8.
8. And if you need to write underneath it that that's 2 cubed, then that might help. 3 cubed. 4 cubed. 5 cubed. 216. 256. 216. 36 times 6. 216. 6 cubed is 216. And then we're going to go one more, because usually they don't go any higher than that. 49 times 7, 349. 343. 343. And then of course it keeps going, but we don't. In case you missed that, I said it twice on accident. We don't keep going. We stay around these numbers. So get comfortable with these numbers, because then it makes this a lot easier. All right, we're going to factor number 1. You're going to want to watch and listen, because I'm going to be done in 15 seconds or less than that, and then you're going to be like, I didn't see it. You're going to have to do another one. First of all, I'm going to recognize that that is a perfect cube. That's divisible by 3. That's how you might want to make a note. This is divisible by 3. That means it's a perfect cube. And then this is a cube, right? So I'm going to factor it. I know it's going to factor to a binomial and a trinomial. The binomial comes from cube rooting what you have in front of you. Cube root of that, what is that? 4, right?
Yeah.
Then I'm going to square those to get the outer elements of the trinomial. That squared. To get the middle term, you multiply those two together. Gotta shift it. Ran out of room. And then the signs are last. What do we always remember?
So,
Same, opposite, always positive. Rare time. So, same, opposite, always positive. All right, let's do the second one. Someone's going to have to read it to me.
y cubed minus 8.
Oh, I love it. Let's go. Let's try it. Can you do it fast?
Probably not.
Not? Oh, okay. Well, it's the second problem. It's all right.
Y minus 2.
Y. I'll do the sign. I always do soap last.
Y squared.
Not in the shower, but you know what I mean.
Yeah.
All right. Y squared.
2y.
There you go.
And then 4.
Okay.
And then minus
Same,
plus.
opposite, always positive. Does it make sense? Try 3 and 4. No. All right. Try 3 and 4. Sorry. If you don't get it, it's okay. We're still here. We haven't moved on. It's okay. You've got this. So,
Oh, she said 4.
okay.
I don't know.
It is it's like whiplash. It is like whiplash. It is fascinating. Read number 3 to me, because I forgot it.
X cubed plus 64.
Okay, read 4. 8 cubed.
8 cubed.
Oh yeah, you can do this.
Where'd you get 8x?
I don't know.
It's not. It's 8 cubed.
8 cubed?
A.
Even easier. You got
Wait,
this.
do we have a fire drill today?
We do? We just had one.
It won't be until the very end of this class.
Okay, I was making sure. I couldn't
We have
remember.
to have 2 in the first month of school.
Alright.
2. I think we get out at 2.
Where we go?
Jinx.
What, I thought
Sorry,
we
my boys are in that phase right now. Bluey up to stop.
Bluey. Bingo.
Alright, you're trying these 2. Have you done them?
Yes, ma'am.
You ready for the answers?
And who's the fan? I mean, they keep it.
Don't be a victim. Ask for help.
Here.
I just want to watch. I'm not even here.
No, I think.
Are you ready?
That was a good one.
Like Archer. He wandered off to the I was wondering if I could last that one.
Oh, wait, I put not in the way to do that, by the way. Yes. Power divided by three.
Why are you looking at yourself in your mirror?
Hey, real quick reminder, when you're taking the cube root of a variable to the exponent, if you're taking the cube root, you're dividing the exponent by 3. So the cube root of x cubed would be x. Don't multiply though. You know that, right? We're factoring. Yesterday was multiplying, now we're undoing it. Oh, yes, so don't worry about the sign. Let's soak take care of the
I know.
sign.
They just feel like a day.
I can do it whenever.
Always positive in your list. So the cube root of this would be x to the first power. Cube root of 64, square those, and multiply them together, and then remember soak. Right? Throw one of these at a friend of yours and blow their mind. Be like, look what I can do. Huh?
I agree.
Now, I think there are some questions on there where I threw something in there to trick you. Yep, number 6. Number 6 has what problem? What issue?
A negative.
There's a negative in the front. You would factor that -1 to the front of it. Wait, what's it say? Minus. Okay. So you would pull a negative out of the whole thing. Now leave the negative there because it's still there, right? This is not solving. This is just factoring. So when you pull GCS out, they're still there throughout the problem. They don't disappear. And my hair just touched the board. That's right. And then now we're going to write cube root squared together squared. Soak. Don't worry about the negative in the front. Still soak. Same, opposite, always positive.
So would that be our final answer? Or do we
Yeah.
have like, okay. I don't know if we'd factor the negative back in or not.
No, that would be your final answer. Yeah. Yes.
So, this with this, like just remove this and just take it back to like
If you were to multiply it completely out, you should get what you started with, which is a way to check yourself if it's the test and you're worried that you've done it wrong. Multiply it out to the side and check it. And that would be a binomial times a trinomial, which would require you to do distributive property, or if you do the box method, you would have to have that third column if you do the box method. 5. What's 5 say? So again, there's a leading negative that needs to go away. Or you can switch these. So there's two routes here. You could just completely switch it. Doesn't matter. If you don't switch it, you have to factor that negative out like we did this one. If you do switch it, there's no factoring a negative out, and you would go straight to, remember I said 1 is a cube. Feels like it shouldn't be relevant, but it is. So this would be 1 minus 6x as the binomial, and then it would be 1 plus 6x plus 36x squared as the trinomial. Right? Let me get my hair out of the way. Hold on. Okay. There's another one. No, it's 8. What's the problem with 8?
Oh, 4's not a perfect square. Perfect cube.
When you look at 8, you should probably recognize that the numbers 4 and 32 are not perfect cubes. But there's a GCF of 4 that you could pull to the front, like we've done the negatives. When you pull that 4 to the front as a GCF, what you would be left with are perfect cubes. This one or the one I just talked about? Yeah. Is it 8? Number 8. And it said 4x cubed. So pull a 4 GCF out. Then recognize that the binomial left is a perfect cube. 4 comes down for the right. Cube root both of them. Square that. And multiply them together. Same, opposite, always positive. That would be it. Sorry, you can change it to X. When we start My Math Lab, they do switch letters, and you do have to use the letter they give you. So okay. That's the spirit. Love your confidence. Yeah. I wonder if they are going to hold that bus. Oh.
Illegal. Yes. Yes.
Did you go yesterday? Oh, you only go over there. So where do you go on Monday, Wednesday? Oh. Gotcha. 1, 2, 3, 4, 6, 7.
1. Plus one. Maybe if you're testing these here.
All right, look at this sheet that you just got. If you need a flow chart to help you with factoring, here's your flow chart. The only thing not on here are cubes, because this is factoring quadratics or 4-term cube polynomials. Let me repeat that. Factoring quadratics or 4-term cubic polynomials. What did we just practice? 2-term perfect cubes, right? Sum or difference of cubes. So this is different. So this flow chart is if you have a quadratic or if you have a cubic that has 4 terms. This should look familiar. You should not have to spend a lot of time on this. If it's a binomial quadratic, check and see if it's a difference of squares, which factors nicely. Take the square root of both terms, and then one's minus, one's plus. See if it's a difference of, oh, I told you wrong, it is on here. This is sum and difference of cubes, which we just practiced. Do you remember the type of quadratic that's a binomial that does not factor? The type of quadratic that's a binomial that will not factor. Doesn't matter what numbers are in it. Let me show you. Okay. I'm going to say not a squared plus b squared. Do you remember learning that if it's a quadratic and it's a plus sign in the middle, it will not factor? It's only when there's a minus sign in the middle.
Oh, yeah.
Do you remember that? Difference of squares only factors if they're both perfect and there's a minus sign. If they're both perfect but there's a plus sign, it won't go anywhere. Now, that's different than what we just did. Look at the difference. What we just did, they weren't squares, they were cubes. There's a difference. So make sure to not get those confused, okay? If you have a quadratic where a is 1, it factors very quickly to the parentheses based on what will multiply to give you C and add to give you B. This should ring a bell. If A is not 1, it's still what multiplies to give you A times C and adds to give you B. Honestly, I don't like teaching these differently because when I'm first teaching kids that are struggling with factoring, I just show them the one way that works every time. So I'm even going to write a 1 here and draw an arch to show you that you would multiply A times C, which would be 1 times C, and then you would find the numbers that multiply to give you that and add to give you B. I'm going to show you an example in just a second. Stand by. It's not.
That's good.
All right. 4-term polynomial. It would start out as a cubic. You're going to factor it by grouping, which is the complete reverse direction of what I taught you yesterday with the distributive property. We went in one direction yesterday. Well, if you're factoring by grouping, it would go the reverse direction. And I'm going to show it to you in just a second. There are examples underneath these, by the way. So here's your flow chart. Let's copy this example to the space, I guess, underneath it. I'll just write small. So we have x squared minus 4x minus 12 right there. I'm going to show you a third or second, however you want to call it, technique for factoring that helps you organize your numbers that some people seem to like. One of them is factoring by just coming over here, writing out the numbers, coming back, plugging it in. Another technique is to draw like an X. This may ring a bell. So you would put a 1 here, you would multiply. You would say 1 times negative 12 is negative 12. And then you would copy B right there. And now it's a guess and check game. What multiplies to give me negative 12 and adds to give me negative 4? 6 and 2. Now it's a sign game.
The 6 is negative.
6 is negative. Then you would double check it. Do those multiply to give you this?
Yes.
Yes. Do they add to give you this? Yes. Then you would go to your parentheses and you would plug it in and factor the GCF out. Is there going to be a GCF here? Say no. No, because A was 1. So it would go straight to parentheses, and it would be x minus 6, x plus 2. Right? Okay. Now I'm going to show you another problem where A is not 1, where you cannot jump straight to this. Okay? So we're going to do this one right here. 3x squared minus 10x minus 8. All right, A times C. Negative 24. B, negative 10.
Negative 12 and 2.
Negative 12 and 2. Double check it. Multiplies to give me negative 24. Adds to give me negative 10, right? Is A 1? No. So you can't jump straight to the parentheses. There's a GCF step involved. 2 ways to do this. I'm going to show you a method that's, I call it the fraction method. It will help tremendously when we get to the more complicated problems that take an entire page. You're going to be thankful for a shortcut here when we get to the hard new stuff. You with me? You got to find shortcuts on the old stuff so that when I throw the long entire page problems at you, I've not lost you halfway through because you ran out of wind. So here's the technique, and I'll show it to you again so you can see like 2 examples. So the technique is you copy, just watch me first, don't write. You copy AX into 2 sets of parentheses. So what is AX? 3x. Then you copy the 2 numbers you just came up with right behind it. Came up with negative 12, came up with positive 2. 1 set of parentheses is always done. Which set is reduced? This one. This is done. It's done. That's not. That has a GCF of 3. So you just come underneath it and visualize to yourself. If I took a 3 out, what would I be left with? X minus 4. Bring this down, you're done. That's the faster way to factor when A is not 1. As opposed to factoring by grouping, okay, so what I've just put on the marker board is what's called factoring by grouping. This technique is the other way to do this. Takes more writing, takes longer steps, Nothing wrong with it. This fraction technique, you could almost argue is the same amount of writing maybe, but you get your numbers, you put them in the fraction, or in the parentheses with AX, and then you reduce whichever one will, and you're done. Okay? Whereas over here, we had to group, GCF, 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 again, and then what's left. Which brings me to 4-term polynomial factoring. Do it this way. So, if you look at, here's the 4 terms, you group them in standard form, and then you pull, you just focus on 2 at a time. You pull the GCF here out, so GCF of that would be x squared. You write what's left. Here you pull the GCF out, write it, write what's left when you divide that out, and then these should match every time. If they don't match, you've done it wrong, or it doesn't factor. Okay? And then you pull that out, which would leave you with x squared minus 5. See it? This is not new. So, if it's been a minute, refresh using the practice problems I gave you. Go to the back. You got 12 practice problems. They are all mixed up. You've got some sum or difference of cubes. You've got some, difference of squares. You've got some with a GCF. And you've got some that are 4 terms and have to factor by grouping. Am I right in guessing that the grouping technique needs another example?
No.
No? Are you good? Maybe one more? Why don't you try number 1 and we'll check it. How do I know number 1 is factoring by grouping? There's 4 terms. And it's cubic. So if you group it, then it's like selective hearing. You're selectively only focusing on the first 2 terms. You're saying what GCF do they have in common, and you write it in the front. So 15x cubed minus 35x squared have what in common?
5x squared.
5x squared. Then you put parentheses and write what would be left if you factored that out by division. You'd be left with 3x minus 7. Then you repeat and say, what's the GCF of the last set? Always go with the sign of the first term in that set. Always. Even if it's negative, that means you need to pull a negative. So it's going to be positive 6. And you always put that sign right there to show that it's either addition or subtraction, not multiplication. And then what's left? 3x minus 7. Now I'm going to change to a highlighter to help you see this. Did you notice that those match? They better match. If they don't match, you factored wrong or it doesn't factor at all. Because now the yellow is now your GCF. You've got this crap here plus this crap here. What do the two pieces of crap have in common? 3x minus 7. I'm going to visualize pulling that to the front like a GCF. And then as I pick that up, pull it to the front, I would be left with 5x squared plus 6. Right? Visualize the yellow being picked up and pulled to the front. And you only write it one time because it's a GCF. And then you would be left with 5x squared plus 6.
On this, I recognize that, but for some reason it has a squared first.
I didn't type that.
Okay. I was just what?
Oh, that doesn't matter.
Okay.
Yeah, it doesn't matter. Remember multiplication, commutative property that we don't ever talk about anymore? The order that you multiply is irrelevant. So whether you wrote 5x squared plus 6 first or second, it's still the same answer. Do y'all have any other questions on this paper as you're looking through them? I already did it. Number 3. What do you notice? There's a sneaky GCF in there. Sneaky. So on your calculator, because those like 126 is not a number you're familiar with. Now 24 and 30, you probably can come up with a GCF for that. You can go to your calculator, math button, arrow over to NUM for number. You see GCF? Anyone doing this?
GCD.
GCD, same thing. Click it. You can only do it with numbers. You can't do it with letters. Type 30, 126, and it will produce the GCF of those two numbers. 6? Yep. It won't let you do 3 numbers. I wish it would, but so you could just pick the 2 biggest numbers that you're not comfortable with, and then double check it. Once you pull that 6 out, now it's a standard quadratic where a is not 1. So let me show y'all that fraction technique again. So if we divide a 6 to the front, so the 6 stays along for the right because it is part of the entire expression. We're going to multiply a times c. I'm going to clever here and do it. 4 times negative 21. Oh my word. Sorry. 4 times negative 21. Yeah. I definitely transposed them. And then b is negative 5. So factors of negative 84 that add up to negative 5. You probably have to guess and check here. Yep. Yes. 12 and 7. Now it's a sign game. Negative 12. Positive 7. Huh?
I learned that my dog now. I'm dead serious. That's 7 weeks ago.
Oh. Mine was 10. All right. Here's that shortcut to factoring when you have a quadratic. Here you go. You write 2 parentheses, and in the front of them is AX for both. AX is 4X. It goes in both. Then behind that goes the 2 numbers you just came up with, and order does not matter here. So I got negative 12 and I have positive 7. then you can see which one's done.
7.
4x plus 7's done. 4x minus 12, what would it basically divide out of both of them? A 4, and I'd be left with x minus 3, right? And then this would be 4x plus 7. You do need to bring that 6 down because it is part of the answer. So the 4, you're just reducing it, and that is something, yeah. In that case, it does just disappear because that's just a little shortcut technique to factoring. Keep working through these. Show me green.